What is motion? When a body does not change its position with time, we can say that the body is at rest. While if a body changes its position with time, it is to be in motion. Ibig sabihin, pag walang paggalaw na nagaganap, ito ay nasa rest state. Pag naman may paggalaw na ganap, ito ay tinatawag na motion sa Tagalog. Linear and non-linear motion. Sa linear motion is a motion in a straight line. Ito yung motion na diretso lang ang movement. Halimbawa dito ay yung kotseng mabilis na tumatakbo sa isang direksyong daanan. Ang non-linear motion naman is a motion that is not in a straight line. Ibig sabihin, ito yung pabago-bago yung direction o hindi straight yung pagtakbo or yung paggalaw ng isang bagay. Halimbawa na dito yung bubuyog na lumilipad. Hindi ito diretsyo kung lumipad pa bago-bago yung direction ng lipad ng bubuyog. Translational motion, a type of motion in which all parts of an object move the same distance in a given time, is called translational motion. Ito yung motion ng isang object na nag-move from one point to another point. So, yung translation motion can be divided into two types. So, this is rectilinear motion and curvilinear motion. Sa rectilinear motion muna tayo. When an object in translational motion moves in a straight line, it is said to be in rectilinear motion. Ibig sabihin, pag pa-straight lang yung galaw ng motion. Halimbawa, dito yung a car moving on a straight road and a tree moving on a straight track. So, next, yung second type is yung curvilinear motion, and an object in translational motion moves along curved paths. It is said to be in curvilinear motion. For example, a stone thrown up in the air at an angle and a car taking a turn. So, for example, sa rotational motion, yung windmill, yung hélice ng windmill, yung each blade ng windmill, nag-move sa iba't ibang axis pero nasa iisang position lang sila. Paikot-ikot lang, di ba, yung hélice ng windmill. Sunod naman na ating mag-aaralan yung free fall. So, ano nga po bang free fall? A free falling object is an object that is falling under the sole influence of gravity. Any object that is being acted upon only by the force of gravity is said to be a state of free fall. So, in Newton's physics, yung free fall is any motion of a body where gravity is the only force acting upon it in the context of general relativity. So, where gravitation is reduced to a space-time curvature, a body in free fall has no force acting on it. For example, yung apple na nahulog sa puno. Yung force ng gravity na mahatak sa apple upang malaglag siya sa lupa. Next naman tayo sa projectile motion. The projectile motion is the motion of an object thrown or projected into the air subject to only the acceleration of gravity. The object is called a projectile and its path is called a trajectory. So, ito yung motion na may kailangan magbigay ng force dito para gumalaw, para mahatak siya or magalaw siya ng gravity. So, for example, sa projectile motion, yung badminton. So, sa badminton, may raketa, diba? Tsaka may shuttlecock. So, para lumipad yung shuttlecock, kailangan mo siyang baluin ng raketa. So, sa force na binibigay mo sa raketa, sa pagpalo dun sa shuttlecock, kaya ito lumipad. At dahil sa paglipad nito, nasa air ito, diba? Yung air, and dahil hindi sa gravity, kaya bumabagsak na hatak sa lupa yung shuttlecock.
And now we are taking a look at the types of graphs that we can draw and the types of information that we can get from them. We start with the distance, which can also be known as displacement or position, for they are all the same things with regards to the graphs. The symbol for distance is x, while the symbol for time is t. What we can get from them, of course, we can get the distance at any given time, to how far it's going, and how far is traveled in a given time. We can also get the average velocity from the slope of the straight line. These two keywords go together, average, velocity. We can also get the instantaneous velocity from the slope of a tangent line to the curve at that point. So if a best fit line is not a straight line, it is a curve instead, we can't get the average velocity from that because the velocity is changing, but we would be able to use a tangent line and get the instantaneous velocity using the slope of a tangent. Now for velocity and time graphs. We use the symbol v for velocity and t again for time. What do we get from those? The easiest again would be the velocity at any given time. Similarly, we could also get the average acceleration from the slope of a straight line. We could also find the displacement of the object finding the area between the line and the time axis. The last type of graph would be the acceleration versus time graph. The symbol for acceleration would be a, and again, t for time. What we can get from them is only the acceleration at any given time. It is the most limited type of motion graph that we can get as far as the information we can get from them. Now on to the graphs when the object is at rest. From what you can see at the first graph, the line shows us that the distance is not getting bigger or smaller as time progresses. For the second graph, its velocity is 0 when the time axis intersects on the y-axis. We would have a VT graph that has a horizontal straight line. For the third, if there's no velocity, then there is no acceleration, just as the line indicates. Now we go to an object moving at constant velocity away, which means the velocity is constant, thus making the distance increase over time. So this of course will be a straight line sloped upwards with the numbers getting bigger while time is moving in a positive direction, as it is the only direction time can move. The fact that the line is straight shows that the rate of change of the distance is constant. As for the VT graph, velocity is not at 0 and its line is above the time axis. Its acceleration value though is 0 as it is not speeding up or slowing down, so it would be a horizontal line on the time axis again. Now for the object moving at constant velocity toward with constant velocity, meaning our line is going to be straight, but towards means that our x numbers, our distance numbers, would be decreasing. It would be a straight line negative slope as x is decreasing and t is increasing. Constant velocity again for the VT graph, but our line would be under the time axis, making it move toward the point of origin. As usual, the acceleration is still at 0 and the line is on the time axis. With the object moving at constant acceleration away, x is getting larger but will result in a curved line upward, meaning that it gets faster. The reason for it being curved is that if we take our tangent line and bring it to the graph, it gets steeper, which means that the object is accelerating. Now for the VT graph, the line is positively sloped as the acceleration is again constant. The line now for the graph for the AT graph would be above the time axis, showing that it is a constant acceleration. Equations of motions. They are only valid when acceleration is constant, motion is constrained to straight line. Velocity time. The relation between velocity and time is a simple one during uniformly accelerated straight line motion. The longer the acceleration, the greater the change in velocity. Change in velocity is directly proportional to time when acceleration is constant. If velocity increases by a certain amount in a certain time, it should increase by twice that amount in twice the time. If an object already started with a certain velocity, and then its new velocity would be the old velocity plus this change, you ought to be able to see the equation in your mind's eye already. This is the easiest of the three equations to derive using algebra. Start from the definition of acceleration, which equals to change in velocity over change in time, expand change in velocity to final velocity and initial velocity, and condense change in time to time. Then solve for final velocity as a function of time. This is the first equation of motion. It's written like a polynomial, a constant term, initial velocity followed by a first-order term, acceleration multiplied by time. Since the highest order is 1, it's more correct to call it a linear function.
Inertia. Bakit nga ba may mga bagay na nagbabago ng estado sa paggalaw? Pag-uusapan natin yan dito sa Newton's first law of motion, which is inertia. Law of inertia. An object at rest will remain at rest, and an object in motion will remain in motion unless acted upon by some external force. Yung unang parte ay may sense, since motionless object typically don't just moving around. Pero yung pangalawa, it contradict our everyday experience. Pag naghagis ka ng bato, hindi siya habang buhay umaandar sa ere. Para sa kariton, kotse o helicopter, para umandar to, kailangan nito ng tuloy-tuloy na force. So, saan nakuha ni Newton tong idea na to? Para maintindihan natin, kailangan natin malaman lahat ng force na nakakaapekto sa paggalaw. Yung mundo natin ay sobrang komplikado. At kapag gumagalaw tayo ay nakakaranas tayo ng wind resistance at iba pang uri ng friction. It is a force that resists our motion. Pinapabagal nito o pinipigilan nito ang pag-apply natin ng constant force. Think of something na sobrang baba ng friction. Tulad ng ice skating. Kapag tinulak mo yung kaibigan mo, mas malayo yung mararating niya kaysa sa tinulak mo siya sa kalsada. Pero kahit na maliit yung friction dun, titigil pa rin yun kasi meron. Now, imagine as Galileo and Newton did, that there was a surface that is completely free of friction. Ngayon, isipin mo, naghagis ka ng sapatos doon sa free friction na yon. Hindi siya titigil habang walang ibang force na nakakapagpahinto sa kanya, katulad ng hindi pa siya bumabangga, ganun. Etong free friction space na to ay matatagpuan sa space. Normal yun sa space na walang wind resistance at friction. Yung motion dito sa Earth, ang special case because most of the universe is in space and very little of it is on Earth. So, mas dapat nating i-consider ang motion doon sa space. Example ulit. Ang kotse, kailangan ng makina para gumalaw ng steady. Kasi merong resistance dito sa Earth tulad ng wind resistance, friction sa kalsada. Pero ang rocket ship, magbubukas lang to ng makina hanggang sa makalabas sa atmosphere. Tapos kapag nasa space na siya, pwede niya nang patayin yung makina niya. At magta-travel na siya sa steady na bilis. Bubuksan niya lang to ulit para lumiko or huminto or magbagal. Force must be applied to get the object moving and again to slow it down or stop. An object will have some amount of inertia that is proportional to its mass. More massive objects have more greater or greater resistance in motion. Imaginein mo, may maliit na bangka tapos may mas malaking barko. Yung maliit na bangka ay kaya ng pagalawin ng hangin at pahintuin kung babangga. Pero yung barko, kailangan nun ng malaking makina at malakas para umandar o huminto. Ganon din sa ping pong ball. Mas madali siyang pagalawin, pipitikin mo lang siya, kaysa sa bowling ball. Sa bowling ball, kailangan mo ng malakas na puwersa at malakas na puwersang pipigil doon para huminto. Ito pa, sa kotse, kapag nabangga ka sa kotse, hihinto yung kotse pero ikaw hindi. Kaya tayo may mga seatbelts. Always wear your seatbelts para safe. So, ayun. Dito na papasok ang net force. If a net force is not zero, an object will there will be some movement, its state of motion. And if it whether is at zero or moving, there will be no movement. Velocity. Tapos na. The law of inertia was first formulated by Galileo Galilei for horizontal motion on Earth, and it was been generalized by René Descartes. Before Galileo, it has been thought that all horizontal motion require a direct cause, but Galileo deduced his experiment that body in motion will remain in motion unless a force such as friction cause it to come at rest. This law is also first of Isaac Newton's three laws of motion, which is inertia.
Law of acceleration, Newton's second law of motion, can be formally stated as follows. The acceleration of an object, as produced by a net force, is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object. So, forces on balance, there is an acceleration. So, pupunta naman sa the acceleration depends inversely upon the object's mass. So, the acceleration depends directly upon the net force. So, ang ano dyan, dapat ang force may unbalance at ang galaw ng isang bagay depende kung sa gaano kabigat o gaano kalakas ang puwersa na binibigay. So, magbibigay ako ng example. Dapat daw may mas mabigat o mas magaan. Yun guys, nakikita niyo yung may dalawang bata na naghihila ng dalawang bato. So, yung isang bata, hinihila niya yung malaking bato, ayun yung may greater mass. So, yung isa naman, yung maliit na bato o mas magaan, ayun ay merong lesser mass. So, yung mabigat na bato, ay kailangan ng greater force para gumalaw. So, samantala naman yung maliit na bato, kailangan niya ng lesser force para ito din ay gumalaw. So, at gayon din, sa law of acceleration, ang galaw o kilos ng isang bagay ay naapektuhan din ang bigat at lakas nito. O mass nito. So guys, mas mabigat, mas mabagal ang kilos o lesser acceleration. At ang bagay naman na magaan ay mas mabilis na kikilos or greater acceleration. So, ang nakalagay dyan, so greater mass only needs greater force and will have lesser acceleration, while lesser mass only needs lesser force, yet will have greater acceleration.
Newton's law of motion. In classical mechanics, Newton's law of motion are three laws that describe the relation between the motion of an object and the force acting on it. The first law states that an object either remains at rest or continues to move at a constant velocity unless it is acted upon by an external force. Hindi ko na siya ipapaliwanag kasi papaliwanag naman siya ng mga susunod na reporters. Newton's third law of motion, law of interaction. These two forces are called action and reaction forces and are the subject of Newton's third law of motion. Formally stated, Newton's third law is: for every action, there is an equal and opposite reaction. The statement means that in every interaction, there is a pair of two forces on the two interacting objects. Yan, ang interaction daw ay nangyayari lang sa mga bagay na nagbabanggaan o nagkaroon ng contact. Kino-consider na action and reaction ang mga force na ina-apply sa mga object na galing lang din sa paligid natin. Di ba nga, may sinabi na for every action there is an equal reaction but opposite direction. Ayan, for example, meron tayong isang golf ball at isang kalamansi. Si golf ball ay nakastay lang in one place, then ibabangga natin sa kanya si kalamansi. Kung gaano kalakas yung force na binigay ni kalamansi kay golf ball, ayun din yung babalik kay kalamansi ng same amount. Yung arrow na nandyan ay yung nagre-represent ng force na binigay ni kalamansi, then binalik naman ni golf ball kay kalamansi. And another example ng action and reaction force spheres, a rocket leaving a launch pad. Ayan, yung rocket na diba, same amount lang yung binigay nilang force na si rocket is gases on rocket and rocket on gases. Ayan, kagaya pa rin ng nauna, runner pushing down on the ground. Ayan, earth on runner and runner on earth. Lucy pushed against Sarah with a force of 540 newtons direct east. A. What a force does Sarah exert on Lucy? B. What acceleration does each person experience? Lucy pushed Sarah 540 newtons and Sarah gave the same force to Lucy of 540 newtons. Ito yung formula A. F equals to MA and A equals to F divided by M. May bigat si Lucy na 60 kg and i-compute natin siya para makuha natin yung total acceleration na naranasan nilang dalawa. 543 newtons divided by 60 kg. Ika-cancel natin yung dalawang 0 kaya magiging 54 divided by 6 kaya magiging 9 meters per second squared. Same lang ginawa natin kay Lucy, 540 newtons divided by 90 kg. Cancel yung dalawang 0, kaya 54 divided by 9 equals 6 meters per second squared. Makikita dyan na kung sino yung may malaking mass, mas malaking mass, siya yung makakakuha ng mas mababang acceleration, which is si Sarah. And si Lucy naman, siya yung may pinakamababang mass, kaya siya yung nakakuha ng pinakamataas na acceleration, which is 9 meter per second squared. Pero parehas lang yung force na binigay nila sa isa't isa.